Right, good day, grade 10 learners. Welcome to our mathematics lesson. I am Sikhulile Ncube. This lesson is proudly brought to you by the Gauteng Department of Education. Right, what are we going to learn today, grade 10s? We are going to learn about literal equations and linear inequalities. I really hope you are settled there. You are ready for the lesson. Okay, let's make sure that we are settled and then we have everything that we need for the lesson in front of us. Make sure that your book is there with you, your calculator, your pen, everything, please. And pay attention. Don't disturb anyone. Okay? Right. Now, this lesson is interactive. We're going to be communicating. Let's discuss things. I don't want to be saying things till the end of the lesson without you giving us your input. Okay? Remember our WhatsApp line 064 748 8913. Please send us your work, send us the questions. Let's get involved in the lesson. Okay? So that you enjoy the lesson. Remember, you learn mathematics by doing it. Okay? Right, now, at the end of this lesson, you should be able to solve literal equations. What are these literal equations? Some of you are asking yourselves, what are these things? Very easy. You'll see that. Very, very easy. Right, by changing the subject of the formula, and then you're wondering now, what is the subject of the formula? It's not difficult. Don't stress. Not difficult. These two things are very, very easy things. The most difficult things is their names here. Okay? Right. Don't stress. Right. Now solve for a variable in terms of numbers and other variables. That's what we're going to be doing today. And then once we're done with literal equations, we're going to do linear inequalities. Okay? Right. Now, pre-knowledge, what have we done so far? Like we say today's lesson is going to be very simple. Do you see this? Because we're going to be using simple mathematical operations. What are these operations? Adding, subtracting, multiplying, dividing, square rooting, cube rooting, squaring, cubing. Basically, those are the operations we're going to be doing. And I know that most of you, all of you actually, you are familiar with this. Okay? Right, and then factorization. We did factorization in our previous lessons, even in previous grades. And then squares and cubes, we're going to be doing that. Square roots and cube roots, we're going to be using that, okay, in today's lesson. Right. Before we move any further, grade 10s, I want us to do an activity, a very, very easy one. It's what we've been doing all along, and then introducing us to today's lesson. Right, there's A, B, and C. I'm going to give you 4 minutes to do these 3. If you're fast enough, you can finish them. But don't worry, I'm going to give you extra minutes, about 3 more minutes after that. But let's have 4 minutes. We do everything. Even if you do not finish, it's fine. I'm going to give you time. Right. Try to do all the 3 in 4 minutes. Then after that, I will tell you what you must do. Let's try. Welcome back, grade 10s. Did you manage to answer the questions? I really hope so. Remember, grade 10, this is a live lesson. If you have questions that you need to ask, you may have to ask them now. Please don't ask after the lesson. Please, the questions that we must get them now, okay? Let's do that. Ask your questions and remember to give us your input, and we'll really appreciate that. Now, let's look at A. What did you do? A, how do we solve for x here? Okay, how do we solve for x? Okay, we do the inverse operations. Do you remember that? Okay, or remember additive inverses. Here there's plus 8 here. How do we get rid of positive 8 here? We must add what? We must subtract 8 from both sides. So it becomes 2x plus 8 minus 8 is equals to 0 minus 8. We have subtracted 8 from both sides. Do you see that? And then now it becomes 2x is equals to minus 8. Do you see that? Because plus 8 minus 8 here is what? Is 0. Okay, and then you must get something like this. Do you see that? Okay, or some people say we transpose 8 and then positive 8 becomes negative 8. It's still okay. Okay, you're not going to lose marks if you use either of the methods. Right, now, what do we do from there? This is what we're going to be doing when you're dealing with literal equations. It's the same concept, so it is very, very important for you to understand. Right, now, divide by 2 on both sides, divide by 2, divide by 2. So what is 2 divided by 2 is 1, remain with x is equals to negative 4. You see that? Okay, can you mark that? And then let's go to B. Did you manage to do B? Did you manage to distribute the 2 there? 2 times 5x, what is it? 10x. 2 times 2 is 4. 5 times 3x is 15x. 5 times negative 3 is negative 15. Did you get that? Do you have something like this? Do you have this one? Okay, right. Mark that if you have that. But now I'm going to give you 1 minute. I want you to finish off this equation. I'm going to give you 1 minute. Let's try. Okay, great tense. Did you manage? Right, how do we solve linear equations? Every term that is a variable must go to one side, and then the constants must go to the other side, isn't it? Right, that's what you said when you're talking about what? The linear equations. So now do you see that? Let me just do that. We have 10x minus 15x. You see that? This 15x is transposed to the left hand side, becomes negative 15x, and then it's equals to negative 15, and then we bring this 4 this side, becomes negative 4, and then like that. You see that? Then 10x minus 15x is negative 5x is equals to negative 19. That's what we have here. And then what we do on both sides, we divide by negative 5. Right, we divide by negative 5. Why is our answer positive? Because we are dividing what? Negative divided by negative. Remember that. So we say divide negative 5x divided by negative 5 is equal to negative 19 divided by negative 5. Do you see that? And then negative 5 divided by negative 5 is 1. And then you see we're dividing negative things here. And then we're getting positive answer. Okay? Mark that if you got it right. Now let's go to the last part. Did you manage? It looks complicated, but it is not. Remember, we did what? Equations with fractions. What do we do with equations with fractions? What do we do, cretins? We get the LCD. What is the LCD in this case? Remember, 7 is like 7 over 1. What is the LCD? We have 2, 4, 6, 1 there. What's the lowest common denominator? It should be 12, isn't it? Now, multiply every term by 12. Multiply every term by 12. Now, it's going to be like this. Okay? Right. We multiply this one by 12, this one by 12, this one by 12, this one by 12. You see? Okay? Multiply everything by 12. And then, now, what is 2 into 12 is 6. So it means outside the bracket x minus 5 there's 6. And then 6 into 12 is 2. Take note of this negative here. Okay? Take note of that negative there. And then 4 into 12 is 3. And then here 7 times 12. Negative 7 times 12 is negative 84. And then you must get something like this. Okay? Right. Now I want to give you 2 more minutes so that you can try to finish off this. And then after 2 minutes, we just get the answer and then we look at our literal equations. Let's try that. Welcome back, cretins. I really hope you managed to do the equation here. Let's distribute 6. What do we get? 6x minus 30 there. Let's distribute negative 2. That's negative 10x. That's positive 26. That's 9x. That's 15. And then minus 84 at the end. So you'll get something like this. Did you get something like this? Let's check. Right. And then what we do, we can collect the terms that have what? The variables, put them on one side of the equation and then the constants on the other side of the equation. But what I did here, because I've got a lot of terms, I tried to simplify the left-hand side and then simplify the right-hand side before I put the terms with variables on one side. So now, if you say 6x minus 10x, those are like terms, is negative 4x. And then negative 30 plus 26 is negative 4. That's why we have that. And then this side, 9x is still 9x. And then plus positive 15 minus 84 then is negative 69. You see, that's why we have this. Now we can bring the ones with x on the same side. Becomes negative 4x minus 9x, because the 9x will be coming this side, and then equals negative 69 and then negative 4 becomes positive 4, like that. That's why we have negative 13x is equals to negative 65. And then what do we do from there? What we do on the left, we must do on the right. That's what we're going to be doing a lot today. So we divide both sides by negative 13. You must get x is equal to 5. Right. Now, let's go to the literal equations. Right. What are they? What are these literal equations? Are equations that consist of variables where each variable signifies quantity, a quantity. Okay, you get formulae. Some of you are doing physical sciences, some of you are doing accounting. You see, I think you have seen formulae in those subjects. Those are good examples of literal equations, and then you just have to substitute your things into those formulae. Those are good examples of what? Literal equations. Okay, right. Now, because we don't just have variables, okay, you just have variables there. We don't have numbers. Yes, we may have numbers also, and then with variables, okay, combined. Okay, so those are literal equations, and we can solve those literal equations. When you're saying solve for r, what do I mean? If I give you a literal equation and say solve for r, it means make r the subject of the formula. I hope by now you understand what a literal equation is. Okay, let me give you a good example. Circumference. How do you find circumference? Circumference is equals to, I forgot, but let me remember, 2 pi r. Okay, now this is an example of what? Of a literal equation. We can make r the subject of the formula. We can make this equation be r is equals to. Okay, if I change this equation and say r is equals to circumference over 2 pi, I'll show you how I've done this. Don't stress. Now I've made r the subject of the formula. That's what we mean by saying subject of the formula. Make r the subject of the formula. If I say solve for r, make r the subject of the formula. The equation must be r is equals to. If I say solve for volume v, make v the subject. V is equals to. Okay? Right. Now, how do we do all these things? How do we do all these things? I'm going to explain this. Let's try to move together. Please don't write everything you see on the slide. Don't write everything. Just the most important things, okay? The examples and the activities, okay? Right. Now, we look at this. Make A the subject, and then we look at A. It's attached to T here. By what? By multiplication. It is attached to U also by addition. But if you check at U and AT, these are two different terms. U and AT are two different terms. Do you see that? Okay, so we have U plus AT. So start by eliminating the other term. U is the other term because they are separated by plus. Start by eliminating that. Now, how do we get rid of this U? Do the inverse operation. Just that, you're done. Do the inverse operation. Look at how U is attached to AT. How is U attached to AT? By addition, isn't it? What is the inverse operation of addition? It's subtraction. If you subtract on the left, what do you do on the right? You subtract on the left, you subtract on the right. Let's do that together. Right, what happened to that thing? Oh, okay. Okay, yes, very good. I was getting stressed. Now, V is equal to U plus AT. Now, we have subtracted V minus U is equal to U plus AT minus U. We have subtracted. Some of you can say, no, this thing was transposed. Still okay. To the left, still okay. U becomes negative. Now, we have eliminated one thing. But A is still attached to T. Can you try to complete this one? Check the operation. What is the operation between A and T? There are four mathematical operations: grade 10s, addition, subtraction, multiplication, division. What's the operation between AT there? Between A and T? It is multiplication. So now, what do we do? The inverse operation of multiplication, what is it? Division. Now divide both sides by A. Let's do that. Just do it now. Yeah, divide both sides by a. What do you get? You say v minus u is equals to 80. Divide by a. Divide by a. A divided by a, what is it? 1. You remain with... No. We want to make what? Now I forgot. We want to make a the subject. Sorry for that, grade 10. Sorry. Now we can make t the subject. Okay, we can make t the subject. It's still okay. It's the same thing, but the question said make a the subject. I was not answering the question by doing that. Now we divide both sides by t. Divide both sides by t. So let's use t here. Let's divide by t here. A is still, that's what we want. And then t divided by t is what? Is 1. Then we remain with a is equals to. Now a is the subject of the formula. A is the subject of the formula. Do we have someone with an answer like this? A is equal to v over t is equals to minus u over t. It's still okay, isn't it? Because the denominators are the same, we can subtract the numerators, v minus u over t. Okay, you see that? Right, very good. Now let's try the next one. Okay, the volume of a cone is given by the formula. The volume of the cone is given by the formula. V is equals to 1 over 3 pi r squared times height. Okay, just give you the information where h is the height of the cone, r is the radius, and v is the volume. Now express the radius of the cone in terms of h and v. Do you see? We are solving for r, we are solving for radius, but we're not going to get a number. The answer that you're going to get is going to be in terms of h and v. It's going to be r is equals to. Right, let me give you a guideline here. Let me guide you here. V is also equals to, you can write this thing as pi r squared h over 3. This thing and this is just one thing. Do you see that? I want you to try the first step. Let's do the first step together. Okay, I'll tell you what you must do. Let's discuss. We want to get rid of this denominator 3. Denominator 3. What do we do? Please say your answers in the classroom there. Right, we want to get rid of the denominator. What do we do? We multiply by it. Right, I want you to multiply both sides by the denominator here. Multiply both sides. This side v, multiply by 3. This side where there's pi r squared height, multiply by 3. And get the answer there. What are you going to get? Let's try that. Just try to be ahead of me. Multiply both sides by 3. Right, you will get something like this, grade 10s. Right, we are saying multiply both sides by 3, and then you get something like this. What are you going to get? What is 3? And then this 3 divided by this 3 here, we get 1. What do you remain with? Start by writing the coefficient here. Okay, usually we start by writing the number. So it's going to be 3v. 3v is equals to? 3v is equals to what? Pi r squared height. Do you see that? Okay. Remember what we want, grade 10s. We want r. This is what we want. We must get that at the end. So r is attached to what? What are the things attached to r here? There's pi and h. How are they attached to r? By which operation? Is it addition? Is it subtraction? Is it multiplication? Is it division? It is multiplication. So if it's multiplication, we do the inverse operation, which is division. You see that? Now let's divide both sides by. Are we going to start by dividing by pi, then we divide by h? No, we can do it once. Let's divide both sides by pi h. I want you to try that step. Divide both sides by pi h. Let's try that. 30 seconds. 30 seconds. I'm not going to go anywhere. I'm waiting for you to try. Pi, divide both sides by pi h. Let's try. Divided both sides by pi h. Right, what do we do? 3v is equals to pi r squared h divided by pi h divided by pi h. What you do on the left, do on the right. Pi divided by pi, 1. H divided by h, 1. What do we remain with? R squared is equals to 3v over h. 3v over pi h. Okay, r squared is equal to 3v over pi h. If you answer the question, what do you think? Is the r the subject of the formula now? Not yet. Not yet. This is r squared. We want r is equals to. So r is squared. What is the inverse operation of squaring? It is square rooting. Okay, so you square root both sides. Remember these great terms. If you square root a square, these are inverse operations, they cancel each other out. We remain with x. Do you remember that? Okay, now I want you to square root both sides of the equation. What do you get? You will get r is equals to the square root of 3v over pi h. Right, how many people got this? Excellent, excellent, excellent. Right, now these are literal equations. Are they difficult? No. No, just do the inverse operation. If it's multiplication, just divide both sides. Addition, just subtract both sides, or you can transpose if you want. Very easy. Okay, are you ready for the activity? I'm going to give you time to try this. I know some of you, I give you work, then you just wait for me to say, to give you the solutions. Everyone must try. Everyone. Okay? Right. Now, this is the activity. I'm going to give you 3 minutes. I want you to try. Solve for L. Solve for L. 3 minutes. Okay, welcome back, grade 10s. Thank you very much. I know there are questions about example 2. What we'll do, let's continue with the lesson, and then at the end, I'm going to explain example 2, okay? And then also try to bring alternative methods so that maybe we can understand, okay? Right. For now, let's just continue, and then at the end, we're going to discuss again. I'll bring alternative methods, and then we make sure that we understand, okay? Right. I hope you'll be fine by that. And then now, what did you do, grade 10s, with this equation? A literal equation. We want to solve for L. We want to solve for L, and L is here. How do we get that to that L? What must we get rid of? We must get rid of the 2 pi. We must get rid of the square root sign. We must get rid of the g. Now, even I can tell you what I have to do here. How do I get rid of the 2 pi? I must divide by 2 pi on both sides. How do I get rid of the square root? I must square both sides. How do I get rid of the g? I must multiply by g on both sides. Done. Okay, if you think you manage to get a hint, try to be ahead of me. Okay, right, let's do it together. So now we divide by 2 pi on both sides of the equation, because the operation here is multiplication. Divide by 2 pi on both sides of the equation. What do you get? 2 pi divided by 2 pi, you get 1. And then what do you remain with? We remain with square root of L over G is equal to T over 2 pi, or T over 2 pi is equals to square root of L over G. How do we get rid of the square root side? Square both sides. Square both sides. So we're going to square this side. We square it like this. Okay, you see that? We have squared both sides. We square this. We square this. What we do on the left, we do on the right. And then the square and the square root, they will cancel each other out. We remain with L over G there. You see that? Now, we still have this G here. How do we get rid of the G? That's division by G. So we do the inverse operation, which is multiplication by G. So we multiply by G on both sides of the equation. Okay? And then what do we get? Multiply by G on both sides of the equation. And then you'll get something like this. Okay? Then G divided by G is 1. You remain with L. Do you see now? L is now the subject of the formula. We have solved for L. We have solved for L. Now L is the subject of the formula. Okay, now do you see how we move from this to this? I hope it's not confusing there. T, this is T squared. Do you see that? And then distributing, we did exponents. You see that the 4 is coming from 2 squared, and then pi squared there. That's why we have this answer. Then times the G. You see, that's why we have that. Okay, you think you can try another one? Interesting equations. Do you see that? Let's try another one. Okay, before we move on to inequalities, let's try the second one. Let's try. Solve for V. Make V the subject of the formula. 3 minutes again. Let's try. Welcome back, returns. I really hope you managed to answer the question. Sorry, in my instruction I said solve for V there. It says solve for R. So that's why I had to write that instruction there. I hope that you are not confused by that. Right, now, we want to make R the subject. And R is here. It is attached to 4 over 3. It is attached to pi. And it is cubed. So how do we get rid of 4 over 3? I'm going to do two methods here. We're going to eliminate 3, eliminate 4, eliminate pi, and then after that we eliminate the cube. Right, now, and then the other method, we just eliminate 4 over 3 once. It's an alternative method, okay? So we start with the first one, where we do it step by step. And then the second one, I'll just do the inverse operation of 4 over 3, which is the reciprocal of 4 over 3. Right, let's do it together. Right, now, how do we get rid of the 3? We multiply both sides by 3. Okay? Right, let's do that. Multiply the left-hand side by 3. Multiply the right-hand side by 3. Something like this. And then 3 divided by 3 is 1. Then we remain with 3v is equal to 4 pi r cubed. You see that? We have managed to remove 3 on this side. We want r, remember. Now, we need to get rid of this 4 pi. You can do it once. Divide by 4 pi on both sides. So, let's divide by 4 pi on both sides. Just steps. Do this, step by step, okay? Okay, you don't need to even think, just step by step. Right, and then divide by 4 pi, divide by 4 pi. We remain with 3v over 4 pi is equals to r cubed. One more operation. What do we do? Opposite of cubing, cube rooting. So what do you do? We cube root on both sides of the equation. So you cube root this side, okay? You cube root on the left-hand side, you cube root on the right-hand side. Then the cube root and the cube, they cancel each other out. You remain with r, and then this is our r. We've made r the subject of the formula. Okay? Right, I was saying here, maybe let me, okay, I'll do it at the end. Right, when I'm answering all the WhatsApp questions, okay? But now, let me concentrate on this. Right, so we have 4 over 3 here. What is the multiplicative inverse of 4 over 3? Or what is the reciprocal of 4 over 3? It is 3 over 4. Okay, tip. 4 goes down, 3 goes up. That's the reciprocal. So now you multiply both sides by the reciprocal of 4 over 3. So it's going to be a v times 3 over 4, that's the reciprocal of 4 over 3, is equals to 4 over 3 pi r cubed times 3 over 4. You see that? And then if you multiply the reciprocal, then 4 divided by 4 is 1, 3 divided by 3 is 1. Do you see that? And then we remain with 3v over 4 is equals to pi r cubed. And then we divide by pi on both sides of the equation. Or someone can even say, I'm going to multiply by the reciprocal of pi. What's the reciprocal of pi? It is pi, remember pi is pi over 1. The reciprocal will be 1 over pi. Remember, dividing by pi is like multiplying by 1 over pi. Dividing by 2 is like multiplying by 1 over 2. Dividing by 10 is like multiplying by 1 over 10. Okay, so here I think the multiplication, if I use this, is going to be better. Now say 3v over 4 times 1 over pi. This is just like dividing by pi, is equals to pi r cubed times 1 over pi. And then pi divided by pi is 1, and then we get 3v over 4 pi is equals to r cubed. Do you see that? We have that thing that we had in the previous one, 3v over 4 pi is equal to r cubed, and then cube root both sides. You'll get the same answer. Okay? Right. That is that. Now, I want us to move on to inequalities. We're left with a few minutes. We'll move on to inequalities. We'll try to be a bit fast so that we can cover, but try to understand. The most important thing is for you to understand. Right. What is an inequality? We didn't have a break because of time. We need to move straight to inequalities. Inequalities have more than one solution. What does it mean? If I'm saying x is greater than 2, how many answers do you have there? They go to infinity, because if I'm saying x is greater than 2, it can be 3, it can be 2,1, it can be 4, it can be 1,000, it can be a million, it can be a billion, because x is greater than 2. If I'm saying x is less than 2, anything that is less, any number less than 2, that is part of the solution. So now we're saying that it is more than, it may have more than one solution. It may have an infinite number of solutions. Hence, it is impossible to write all the values in the solution. So we can't write all the values. So that's why we use the symbols for inequalities. So we're going to be using less than, greater than, less than or equals to. If I'm saying x is greater than or equals to 2, 2 is part of the solution. But if I'm saying x is greater than 2, 2 is not part of the solution. So here, the number that we're talking about is going to be included. And then here is greater than or equals to, less than or equals to, greater than or equals to. Okay, remember these symbols. If you multiply or divide both sides of an inequality by a negative number, the inequality sign changes. This is mathematical. It's not like people just decided to say if you divide by negative, just change sign. Let me show you how. Right, 3 is greater than 2. Do we agree? 3 is greater than 2. Do we agree? Let's multiply these two numbers by negative 1. We multiply 3 by negative 1. We multiply 2 by negative 1 and see what you're going to get. You'll get negative 3, negative 2. Now, which one is greater now? Which one is greater? Negative 3 and negative 2. Negative 2 is greater than negative 3. Do you know that? Check the number line. Negative 2 is on the right of negative 3. So negative 2 is greater than negative what? Negative 3. So the sign is changed. Now negative 3 is less than negative 2. Do you see that? So if you multiply or divide the inequality by a negative 1 or a negative number, the sign changes. It's a concept that you'll find in the exams. It's always there. Please remember that. So here the sign from greater than changed and became less than. Greater than or equals to change and becomes less than or equals to. Please don't forget that great tense. Adding or subtracting a number to or from both sides of an inequality does not change the inequality sign. Now, because I'm talking about multiplication and division here, not adding and subtracting or transposing. Ne? If you are transposing, the inequality sign does not change. Are we together? Right. I hope you understand. Now, solve for x. If you check these inequalities, are actually our what? Equations that we did when you're doing the baseline activities. Do you remember those baseline activity questions? So I'm going to be fast here because we have done them. We did them when you're doing the baseline. Now, instead of an equal sign, we have an inequality sign. That's the only difference. Okay? So don't say you're moving fast. We've done these questions. Okay? Right. Now, what did you do? We distributed 2 here, distributed that, distributed that, distributed that. And then we got this, isn't it? Now, transposing, bringing the 15x to the left-hand side. Does it change the sign? No, it doesn't change. Okay, transposing, even if it's negative. Okay, because some people say, no, 15x is positive there. Even if it's negative, transposing or adding or subtracting on both sides does not change the sign. Okay, so you'll get your answer like this, because 10x minus 15x is negative 5x. And then minus 15 minus 4 is negative what? 19. And then what do? We are dividing by negative 5. What will happen to the sign? It's going to change and become greater than. Okay, greater than. You must know. Sometimes I do this, sometimes I forget which one is greater than, which one is less than. We've got our different ways of doing things. Okay? Some people talk about the crocodile eating this and all that. But I just use my hands. I know my right hand. If I do this, my right hand will give me greater than. If I use my right hand, it's for greater than. If I do this with my left hand, it gives me my less than. So I do that as an adult. Remember. So you can do those things. It's fine. In the exam, you just do it. Which one is greater than? Oh, this is greater than. Which one is less than? This is less than. Okay. Find your own way. Find your own way of remembering these things. Okay. So negative 5x less than negative 19. We're dividing by negative 5 here. And then what happens to the sign? It changes. Do you believe that you get a mark for that? For changing the sign, it's a mark. Okay? Right. Please take note of that. And then this is on the number line now. You don't need to write all the numbers, just the solution. Why is this one open? Because 19 over 5 is not included. X is greater than 19 over 5. So 19 over 5 is not included. So we have an open. Do you say open dot? It can be a dot, open dot. It's an open like this. It's just a circle. Okay, just a circle like that. Okay? Because the 19 over 5 is not included. It's not part of the solution. X is greater than. Okay? Right. Remember this. If you forgot, you can check your solution for the baseline. The only difference now is the inequality sign. Okay? I want you to do everything. You can check the baseline activity. And then the last part, I want the solution and the diagram, the number line diagram. Okay? Let's try that. I'm going to give you 2 minutes for this because we have done the most part. Okay? The solution part is one which is left. 2 minutes. Let's try. Welcome back. Did you manage grade 10s? Let's see. Right, illustrate your answer on the number line. LCD is 12. We did this, and then we multiplied everything by 12, and then we got this. And then we distributed our coefficients. We got this, and then we simplified our answer to this. Okay, we did this, like I said. Okay, and then now negative 13x is greater than negative 65. So what we do here, the sign changes. Okay, it's not like always the sign changes. Remember, it only changes if you multiply or divide by negative. Okay, and then you illustrate this on the number line. So it means x is less than 5. Still not included. 5 is not included. Okay, right. And then the last one, I'll try to explain this one. Now, there is nothing difficult about this question. What you do on the left, you do on the right. Okay, so what you do on the left, you do on the right. So if you check this, it's like we've got two things here, -7 and this x minus 3. We have left and right, and then also we have this part from there, which is x minus 3 and what? And x minus 3 less than 9. So what you can do here, what you do in every section, you must do. If you add 3 to one section, then you must add 3 to the rest of the sections. Okay, what do I mean by the sections? I am saying we have -7, which is this, and then less than or equals to x minus 3, which is this part, and then we have the 9 here. So if I add 3 here, I must add 3 there, I must add 3 there. So you must do everything, same thing to all the sections. Okay, so here the inverse operation of -3 is +3. So we're going to add 3 in every part of the inequality. So it's going to be -7 plus 3, and then x minus 3 plus 3, minus 3 plus 3 is 0, you remain with x, and then 9 plus 3, you see we have added 3 everywhere, and then x is equals to what? It is between -4 and 12. This is an interval. This is an interval. Your x is between -4 and 12. And -4 is included because x is greater than or equals to -4, or -4 is less than or equals to x. So now for -4, it has to be shaded because it is included. This is an interval, grade 10s. We're going to use this a lot. Grade 10s, remember that your x is between these two values, these two critical values, when you write it like that, okay? X is greater than -4 but less than 12. You see that? Greater than or equals to -4 but less than 5. So less than 12. So it's an interval. X is between -4 and 12. -4 included. Okay? You think you will understand that? Please try to look for some inequalities which are similar to this and try to solve them. Okay? Right. I have one example for this type, and then now I want us to go to our WhatsApp part because people ask questions, and then we conclude our lesson. Okay? Right. The homework. Can I give you 1 minute to copy the homework? And then after that, we go to our WhatsApp and then interaction, and then we try to answer. I have 2 questions, and then we'll just look at those and then we summarize. Okay? Try to copy these questions in 1 minute. Welcome back, returns. I really hope you managed to copy. Sometimes if I give you like 2 questions like this, someone may copy the second question, and then someone copies first question so that you're fast, and then at the end you can what? You can copy from each other, isn't it? So that we don't lose time. Right, now let's look at the questions that we got. Mabopani Secondary School, thank you very much for the question. We really appreciate you interacting with us. Your question was this part, maybe you did not understand this, how we're solving for R, isn't it? Okay, let me just redo it. Maybe you missed something. I'll try to use the 2 methods. Right now, what we did here, we multiplied by 3 on both sides because this 1/3 is like dividing by 3, okay? So we said 3 times V, or V times 3, is equals to 1/3 pi R squared height times 3. You see that? We've multiplied by 3 on both sides. And then 3 divided by 3 is 1. So you remain with 3v is equal to pi r squared height. Now, we want r. You see that? We want r. So now we can even write this thing as 3v is equal to pi h what? R squared. Do you know that? Multiplication is what? Commutative. Do you know that? Okay. A times B is just the same as B times A. So we can rearrange these things. So it's pi h. We can write it like this. Ne? And then to get rid of this pi h, we can divide by pi h on both sides. And then pi h and pi h, they cancel each other out. So we remain with 3v over pi h is equals to r squared. Then we square root both sides. Square root of 3v over pi h is equals to r. Okay? We said also we can say, let's multiply by the multiplicative inverse of 1 over 3, both sides. So you can say v times 3 over 1 is equals to 1 over 3 pi r squared h times 3 over 1. 3 divided by 3 is 1. Then we remain with 3v is equals to pi r squared h. And then if we check this part here, and then this part here is now the same, then we can continue the same way we did here on this side. Okay? I really hope you understood that and you got what you needed. Right, now the second question, we did not get the name of the school, but it was solving for L. T is equal to 2 pi, and then L over G. Okay? Then we divide it by 2 pi both sides. Okay? And then we squared both sides. Square this, you square this. Okay? Right. And then let me remove the bracket before we even complicate things. This becomes t squared. And then 2 squared is 4. And then pi squared. You see, is equals to L over G. And then you multiply by G on both sides. You will get t squared 4 pi squared G is equals to L. See that? That's what you're supposed to do there. Right. Thank you very much. We really appreciate this. Let's get to our questions. And if you ask a question, the question may also help someone else. So we need to get your questions so that we can assist each other. Right. Let's summarize our lesson, grade 10s. Do not forget to change the inequality sign. I think I brought a lot of examples where we're changing the inequality sign after dividing or multiplying by a negative number. And then mathematical and scientific formulae are good examples of literary equations. I think some of you, we are doing physical sciences, you have seen that we use some of the formulae that are used in physical sciences. So you're going to apply this a lot in the other subjects, even in mathematics. Right. Thank you very much, grade 10s. We really appreciate having you in our lessons, and we hope that you are benefiting from them. Continue working hard. Take care of each other. Respect yourself. Respect others. Respect your colleagues. And remember to sanitize, social distance, and to always wear your mask. Goodbye.